telling you, I love this class. You guys are amazing. Hello, hello, hello. Lamont, how are you? Jaden, how are you? You doing good today? So glad you're here. Okay. As always, our class announcements. Please don't share any personal information for your safety and the safety of others. I'm good. Thank you so much for asking. I appreciate you. And then remember to keep your behavior, language, and webcam school appropriate and respectful at all times. Again, your participation and you guys engaging with the material, I can't tell you how much that I appreciate that, and just dearly love that. Love it, love it, love it. Love this class, because you guys do participate and engage. And then always remember that these sessions are recorded and distributed for learning purposes. Okay. So here is our week. Today, we're going to be looking at some trends in the periodic table. We're going to take our notes 2E. And tomorrow is a holiday. We have no school. So you've got a 3-day weekend. Now, before I go any further, I want to show you how to get to your engagement playback room. Okay. So again, if you click on your courses and then click on our class, that will take you to our homepage. Okay. Scroll down here, and do you see where it says course link to Engagely? Click on this. And when you click on this, it's going to bring you to our class. And because we're having class right now, I can't open our playback room, but I'm going to show you this recording. Okay.
Hello, students. I'm going to show you how you can access the playback room for an Engagely class session using the calendar.
So I'm going to jump up here to where she gets to the classroom.
I would normally click.
Okay.
Okay.
So she's using
to get
the
into my live session,
link,
but in this case, I'm specifically trying to get into the play.
Okay. So here is Engagely playback room. Mine I have in dark mode, so it's dark, it's not light. But do you see this link right here? That link right here, it says playback room. Okay, you're going to click that playback room, and when you click that playback room, this button becomes yellow, and you click that yellow button, and that is going to take you into your Engagely playback room. Okay, so again, if you look on our homepage, you can just click this link right here and then click on that link that says playback room. So Danny, does that help? Yeah, a little bit. Hope so. Hello, Ahmed. Hello, hello, hello. Ian, I'm so glad to see you. I hope you're feeling better. Hello, Karina. Welcome, welcome. Okay, I'm going to assume that's good. Now, everybody go to your announcements page. Yay, good, 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 good. Thank you, Danny. If you go to your announcements page, remember we're on week 2. Scroll down to Thursday, and it says Notes 2E, Trends in the Periodic Table. And this is the notes that we're going to take today. Okay? So, okay, thank you. I'm so sorry, Ian. My sister gets migraines, and They are the worst. They are just horrible. So I feel for you. If it starts getting worse, so you let me know, okay? Notice that we're going to finish Unit 2 today. And that means when we come back on Monday, we're going to have an exam. So be sure to come to class because it's an open note exam, right? So I'm going to give you the notes that's going to help you pass that exam. Today, we're going to talk about groups on the periodic table. We're going to talk about families on the periodic table. We're going to talk about electronegativity. And then we're also going to talk about periods on the periodic table and why they call it the periodic table, right? And then introduce you a little bit to the concept of electronegativity. So we've got a lot of things that we're doing, but we're going to get started now. So go ahead and let me know you've got your notes open and you are ready to get started, okay? Thank you, Kaylin and Lamont, Danny, Michaela. Thank you, Karina, Jesus, Ian, Jaden, Australia, Yanni, Ahmed. Dulce, you doing okay? Ryder, you okay? Awesome, awesome. Here we go. Let's do it. So if I look at this, all of these elements are in group 16, okay? Can anybody see anything that is the same? Or tell me in the chat box what's different about these pictures. Either one. Tell me something that's the same or something that's different. I know they're all in group 16. The sizes, yeah, for sure. They get, oh, Danny, yeah, 100%. So if I look at the sizes, right? And I notice, so this is oxygen, right? And this is oxygen's nucleus. And then there's two electron shells, right? This is sulfur. And sulfur has 1, 2, 3 rings. Yeah, Kaylin. Selenium has 1, 2, 3, 4 rings. Tellurium has 5 rings, and polarium has 6 rings. So they get bigger and bigger and bigger and bigger with more and more electrons. But what is the same, and Danny and Kaylin both got this, is they all have 6 valence electrons. And they have 6 valence electrons because they are in group 16, right? Yeah, exactly. So amazing. That's perfect. Yeah. So they all have the same number of valence electrons, but they have different number of shells, and they get larger as they go down the period. So a row on a periodic table is called a period. Okay, so this is question number 2. This is a period, and periods in this, so every atom in the same row, the same period, have the same number of shells. Period 1 only has 1 shell. Period 2 has 2 shells. Period 3, yes, has 3 shells, right? Yeah. So it's pretty cool, right? Yeah, it's amazing. Okay, thank you, Dulce. Thank you, Ahmed. Ayani, Australia, Jaden, Jesus, thank you, Danny, Lamont, Michaela, Kaylin, thank you, thank you, thank you. Ryder, Karina, you good? Yeah, there we go. Okay, so that's a period. A column, which we've already learned before, a column has is called a group or family. Okay. And elements in the same group have the same number of valence electrons. Okay. Thank you, Dulce. Thank you, Jaden and Jesus. Thank you, Danny and Lamont, Michaela. Thank you, Ryder, Danny, Kaylin, Ian, Estrella, Ayani, Ahmed. Karina, you good? Yeah, awesome. Okay, so again, groups are my columns. They go down. They have the same number of valence electrons. Periods go across. They are rows, right? And they have the same number of shells, of electron shells. So we know that atoms want a full outer shell, and that is the octet rule. They want, okay, Australia, when you say number one, or you mean technically this second question, this one? Yeah. Yep. Okay. You got a screenshot. So you want me to wait? I can wait for you. You're good? Did everybody get all of question two? Because I didn't have some of them circled or boxed, I guess. Yeah. Okay. You didn't. Okay, Ian, Danny, go ahead and finish this out. Yep. I'll wait. So elements in the same period have the same number of shells. I should have boxed that. And the smallest shell only fits 2 electrons, and the biggest fit 8. Okay, Ian's good. Danny, are you good? Yeah. Everybody got question 3? Same number of valence electrons? Yeah? Okay, perfect. Okay, so again, groups go down, periods go across. And we know, because of the octet rule, that atoms are reactive because they don't have a full outer shell. But there are some exceptions to that. And these, okay, Dulce, tell me what you need. Okay. So these, the exception, the atoms. Okay. Yeah, that'll work. I also put it in the chat box for you. So just start right here with question number 4 and put noble. Okay. And guys, notice that it is noble, not noble gases. Okay. Yeah, it's noble. So the noble gases already have a full outer shell. And so noble gases are stable. They are not reactive. They don't want to bond with anybody else. Okay. And that's okay. 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 So question number 5. Okay. Some elements react really, really quickly because they're very close to being stable. For example, group number 1, okay, it's super easy for group number 1. They only have 1 valence electron. So it's super, super easy for group 1 to lose 1 electron. And so any chance they get, they're going to get rid of that electron. And that makes them very, very reactive. Same thing with group 17. Group 17 only needs 1 electron. And so it's going to steal an electron any chance it gets. And that makes group 17 super, super, super reactive. So the closer they are to being stable, the more reactive they're going to be. Okay. Thank you, Ayani in Australia. Jaden, Ian, Jesus. Thank you, thank you, thank you. Ahmed, thank you. Kaylin, Danny, Lamont, Michaela, Ryder, Karina, they'll say thank you, thank you, thank you. Perfect. Okay. So these are the ones, thank you, Karina. These are group 1, 2, and group 17 are the most reactive elements. Again, group 18, they are what is called inert. They are not reactive. They're not going to bond. They are very, very happy just the exact way they are. So if I were to ask you, which one of these elements do you think would be the most reactive? Metals with 1 valence electron, metals with 2 valence electrons, or metals with 3 valence electrons. Tell me, which one do you think is going to be the most reactive because it's the easiest? Yeah, exactly. You are right. Yeah, it is A, alkali metals with 1 valence electron, because it is so easy for them to just lose that 1 valence electron. Okay. Yeah, absolutely 100%. Super, super duper easy for them. Okay. Thank you, Ayani. Thank you, Danny and Lamont, Michaela, Kaylin, Ryder. Thank you, Australia. Karina, Jaden, Jesus, Ian, Dulce, Amen. You good? Yeah, perfect. Okie dokie, Panooks. So, how about this one? Okay. Which one of these is going to be, look at Karina, she's already gone. Which one of these is going to be the most reactive? A pictogen with 5 valence electrons, so they need 3 more. A chalcocene, which has 6 valence electrons, so they need 2 more. Or a halogen with 7 electrons that only need 1 more. Okay, what would be the easiest? Because whichever is the easiest, that's the one that's going to be the most reactive. Okay. Okay, thank you, Ian and Jesus. Thank you, Jaden, Karina. Thank you, Danny, Lamont, Michaela, Ryder. Okay, Kaylin, you doing okay? Ayani, Dulce, Ahmed, doing okay? Perfect. Yay. Thank you, thank you, thank you. Fantastic. So that's question number 7. Okay. And again, it's going to be the one that's the easiest, that's going to just jump ahead and try and get that done. Okay. And that's what makes them so reactive. So I want you to look at question number 8. Okay. We're going to talk about some of these groups. Okay. Group 1 are our alkali metals. They are super reactive. In fact, they are the ones that we looked at and watched that video where they exploded in the water. Okay, so they're super, super reactive. They have 1 valence electron. So that's super, super easy. And that's what makes them so reactive. Group 2 are the alkali earth metals. They are reactive because they only have to lose 2 electrons, but they're not as reactive as our alkali metals. Okay. So they have 2 valence electrons. Now, when we look at the transition metals, remember, these are the ones in the middle that I told you don't follow the rules, right? I do want you to know that the iron family is group 8. Okay. They're very, very strong, just like what you think about iron being, right? And they have very high melting points and boiling points. Okay. Copper is in group 11, and we call this the coin edge family because copper, silver, and gold are all in this group, and we use them to make coins. Okay. And they're really great conductors of electricity. Okay. So that's group 8 and group 11. So double check, make sure you got your question 8 correct. Okay. And then let me know that you've got them all okay. Thank you, Dulce. Thank you, Ahmed, Australia, Jaden. Thank you, Lamont, Michaela, Ryder. Okay, Danny, Kaylin, Karina, Ian, Ayani, Jesus, you good? Question 8, you got them? No, you're good. You're fine. Don't ever apologize for that. Never, 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 never. Okay, I'm hanging. I'm waiting. No worries. I just want to make sure that you're good. That's my goal. Okay. Okay. Perfect. Thank you. Thank you. Thank you. Okay. So now Again, you can look at question number 19 or number 9, question 9, and we're going to do not these two, but the next we'll do those. Okay. Group 13 is boron. This is a metalloid. All the others, though, are metals. Aluminum, gallium, iridium, and thallium are all metals. That this is so. Then we have group 14. And that contains carbon. Carbon is the building block of all living life. Silicon also is in this group. And we talked about how silicon is a really, really important semiconductor for our electronic devices. Okay, this is where question number 9 comes into play. So group 15 are the nicotins. Okay. And nicotins contain 2 nonmetals, 2 metalloids, and 1 metal. They all have 5 valence electrons, and they want to gain 3 more. Okay. Then we have group 16, which are the chalcones. Most of these have a really, really strong and unpleasant odor. Sulfur smells like rotten eggs. It's disgusting. It is gross. Okay. So that's 15 and 16. Then we also have the halogens, which is group 17. And these are the ones, again, that have 7 valence electrons. And so they only need 1 more. And because of that, they are super, super reactive. I've got a little video clip I want you to look, I want you to watch of the halogens. Okay, here we go. And fluorine is in group 17. It's a halogen. So there you go. There it is. Those are the two most reactive elements on the chart. The alkali metal, right, which was cesium that they were working with, and then the non-metal that was the most reactive is group 17, the halogen with fluorine, right? And then, of course, we've still got group 18, which are the noble gases. These guys are non-reactive. Remember, that means they are inert. They are stable. They have 8 valence electrons in their outer shell. They are very happy campers, just the way they are. So, question number 9. Did you guys get it? Get all of them? Give me thumbs up if you are good with question number 9. If you have a question with number 9, give me a thumbs down and I can help with it. No? Okay. I saw all thumbs up. Yay. Good, 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 good. Okay. Now, which are the 2 most reactive? Which ones are the closest to being stable? Remember, these are the ones that are going to be the easiest to get to a full outer shell. Okay, which 2 of these? Is it going to be group 1 with 1 valence electron, group 2 with 2 valence electrons, group 13 has 3, group 14 has 4 valence electrons, group 15 has 5 valence electrons, the chalcogens, which is group 16, have 6 valence electrons, the halogens have 7 valence electrons. Which are the closest to being stable? They either need to get rid of a very, very few valence electrons, or they need to gain very, very few valence electrons. Remember that it is not group 18. The noble gases already have their full outer shell, so they are happy, happy, happy. Yes, Danny, you got it. Woohoo! 100%. On fire. Thank you, Jesus and Jaden, Ian, Yanni, Ahmed, Danny, Lamont, Michaela, Ryder. Thank you, thank you, thank you, thank you. Okay, Dulce, Kaylin, you good? Perfect. Thank you, thank you, thank you. Okay, so now, if I look at this, right, here's silicon, phosphorus, and sulfur, okay? I know all I have to do is look at the atomic number to tell you how many protons silicon has. Silicon has 14, phosphorus 15, sulfur 16, right? So what happens as I go from the left side of the periodic table to the right? Do the number of protons, do they increase or do they decrease? Let me know. What do you think? Do they increase or decrease? Yeah, they increase. The number of protons from left to right increases, right? Okay, so with that knowledge, I want to introduce you to a new concept, and that is electronegativity. Electronegativity is an atom's ability to attract electrons, okay? And if you look on a periodic table, it increases as you go up on the columns and as you go right across the period. The very most electronegative element is this guy right here, and that is fluorine. Okay. And that's what makes him so very reactive. He wants to gain one more electron, and he is very, very attractive to electrons. Okay. Do notice that noble gases are excluded. So when I say up and left, that does not count group 18. Okay. So give me a thumbs up. Are you good with question number 11? Give me a thumbs down if you need just a little bit more time. Thank you, thank you, thank you. Perfect. All I see is thumbs ups. Perfect. Okay. So here, as we move left to right in the periodic table, you'll see that the number of the electronegativity is going to increase. Okay. It increases as you go from left to right. Okay. And that's the answer to question number 12. So as you go across a row, the one on the farthest right, except for the noble gas, never, ever, ever do I count the noble gas in group 18. Okay. These guys all over here are the most electronegative. Okay. Thank you, Ayani in Australia, Jaden, Ian. Thank you, thank you, thank you. Michaela, Ryder, Lamont, Danny. I appreciate you. Thank you, Kaylin. Thank you, Jesus. Dulce, Ahmed, you good? Okie dokie. Yay. So here we've got these elements, and I've circled them right here. Notice that we are only looking at groups 1 through 5. Okay, so noble gases are not in here. Which one of these do you think is has the most electronegativity? Is it going to be potassium, calcium, scandium, titanium, or vanadium? Which one is the farthest one on the right in this purple box? Which one is the farthest one on the right, guys? Yeah, you're right. It's vanadium. Exactly. Good job. Thank you. Yeah, it's vanadium. In that row, it's the one that's farthest on the right. Okay. Thank you, Ahmed, Australia, Jaden, Kaylin, Jesus. Thank you, thank you, thank you. Michaela, Ryder, Danny. Thank you, Lamont. Perfect. Thank you, Dulce. Ian, you doing okay? Awesome. Okay, now look at this one. Okay, we've got another box. Okay, notice that this one goes from group 13 all the way over to the noble gases. So right off the bat, I'm going to cross out krypton, because krypton is a noble gas, and noble gases, they are happy just the way they are. So they are not attractive to electrons. Okay. Yeah, it's bromine. Great job. Awesome. It is bromine. Exactly right. Easy peasy, lemon squeezy. Thank you, Ahmed. Thank you, Danny, Lamont, Michaela, Ryder. Thank you, Jaden and Kaylin. Ayani. Thank you, Ian. Australia. Thank you, thank you, thank you. Hey, Jesus, you good? They'll say. Ready, ready, ready. Perfect. Sweet. Okay, so that's 14. Now, here's another one, okay? This one you're going to complete on your own, but I want you to draw your attention to this. Group 18 is counted, okay? So you know right off the bat, there's one you got to cross off automatically, okay? Once you cross him out, then look and see which one is the farthest to the right, okay? Thank you, Jaden. Thank you, Ryder and Danny. Michaela. Yeah, you're on fire. Absolutely. Thank you. Thank you. Thank you. Thank you. Awesome. Thank you, Yanni, Australia, Jaden, Jesus, Ahmed, Ian. Thank you. Thank you. Thank you, Dulce. Kaylin, you good? Yeah. Lamont, thank you. Okay, so that's question 15. Now, remember that my periods, as I go from left to right, they also, not only does that electronegativity gets bigger, right? But the atoms actually get smaller. And so smaller atoms can attract electrons better, okay? They can attract electrons better. Okay. Give you another 10 seconds or so to type in that word. Thank you. Okay, thumbs up. You guys are all good? Do I have any thumbs down? Or everybody good? Perfect. Yeah, sweet. Okay, now, when I look at the size, okay, remember that they have the same number of shells, but they get more and more protons. And the more protons there are, the shells pull in tighter, okay? And that's what makes the atoms smaller, okay? And more, when they're smaller, they're going to have more electronegativity. So question number 17 is smaller. Awesome. Thank you, everybody. Yay. Thank you. Perfect. Okay. So, which of these is most likely electronegative? Electronegative. This is question number 18. Notice we're going from groups 13 to 17. So this time, do not cross one off. Okay? Do not cross one off. It does not include the noble gases, right? Yep. Yep. Awesome. Such a good job. Thank you, Ryder, Michaela, Danny, Lamont, Jaden, Ian, Kaylin, Australia, Ayani, Dulce. Jesus, you good? Yeah? Perfect. Okay. So remember, a row is called a period. A group is called a family. Okay. Now, question 19, it says complete on your own, but what I want you guys to do is grab an annotation, grab your marker, grab a highlighter, and let's do this together because they're not equally distributed. And I want to make sure you guys get this right. Okay. So a row, is a row called a period or a group? What do you guys think? Grab a marker. Tell me, what do you think? Okay. I'm going to, yep, good. You guessed again. Yes, it's a period. Awesome, awesome, awesome. And that means a column is called a what? A column is a group, right? Yeah. Okay. Now, is it a group or a period that tells us how many valence electrons there are? Valence electrons. Is that going to be a group or a period? Is it? Yes, it's a group. Excellent. Okay. So which one tells us how many shells there are then? Yeah, that's the period. Exactly. Now, here's where it gets tricky. Okay. So I'm just going to kind of clue you guys. This is where it gets tricky. Let me see. I'm going to pick red. A group has similar properties because they have the similar number of valence electrons. A group is also called a family. And that's where this question is sort of tricky. There's a lot of groups in there, and there's only 2 of them that are periods. Okay. So go ahead and grab your notes. Make sure you get those right. Okay. Before we move on. Okay. Okay. So are we good? Give me a thumbs up. If you need more time, give me a thumbs down. Okay. Yeah, I see thumbs ups. Yay. Perfect. Thank you, thank you, thank you, thank you, thank you. Okay. I think we're golden. Sweet. So remember, as atoms get smaller, they get more electronegativity, right? And so that means that if you look at this example, lithium is going to be the most electronegativity because it's the smallest. The one that has the least amount of electronegativity is francium because it's so ginormous, right? Okay. Yeah. They'll say, you had it before I even put it up there. That's excellent. Thank you, Ahmed. Thank you, Dulce, Yanni, Australia, Jaden, Kaylin, Michaela, Ryder, Lamont. Thank you, thank you, thank you. Danny, you doing okay? Ian, Jesus. Yeah. Yeah. Okay. So that's question 20. Now, which of the following statements is true about electronegativity. Okay. Tell me which one is true. Is it that larger atoms tend to be more electronegative or smaller? Absolutely. You got it. 100%. Okay. Awesome. Okay. Ian, you doing okay? Perfect. Okay. So if I look at a group, a column, right? That's my family. I get a shell added every time I go down the rows. And that means that my electronegativity is going to decrease as I go down. The electronegativity increases as I go up. Okay, as the size of the atom gets smaller, there's more electronegativity. Okay. Thank you, Ahmed, Yanni, Australia, Jaden, Kaylin, Jesus. Thank you. Michaela, Ryder, Lamont, Danny. Amazing. Dulce, Ian, doing okay? Yeah. Perfect. Okay. So at the top, more electronegativity. At the bottom, less electronegativity. So how about this one? Okay. If you grab a pen, a marker, or a highlighter, which one is going to be most electronegative out of this one? Is it carbon, silicon, germanium, tin, or lead? Yeah, exactly. It is carbon because carbon's up here at the very tippy top. Yeah, excellent. That is awesome. Yeah. So it is carbon. That is the answer to question 20. Okay. Question 23. Okay. Next. Thank you. Okay. Which one of these is most likely electronegative? And this one is complete on your own. Okay. So again, look at these and decide which one of these is going to be the smallest. Which one of these is the smallest? Yeah, 100%. Thank you, Dulce. Thank you, Ahmed in Australia. Thank you, Michaela, Ryder, Lamont. You got it. You are on fire. Jaden, you doing okay? Got it. Yep. Danny, you good? Perfect. Okay. So almost there. So remember, as we go to the right, it gets more electronegative. And as we go to the top, it increases in electronegativity. That means also, if I have a box of elements, the one that is most electronegative is going to be on the right in the upper right-hand corner. So out of these, it's going to be sulfur. Okay. So that is sulfur for question 25. I just look in the upper right-hand corner and I make sure it's not a noble gas. Do make sure it's not a noble gas. But other than that, it's the upper right-hand corner. Thank you, Ryder. Thank you, Lamont. Thank you, Kaylin, Jesus, Ayani, Ahmed, Jaden. Thank you, Michaela and Danny. Australia, Ian, Dulce, doing okay? We only have 2 questions left. Perfect, perfect. Yay. Okay. Question 26. Which one? This is a complete on your own. Remember, look in the upper right-hand corner, right? Yep, yep, yep. Thank you, guys. Australia, doing okay? Yeah? Got it, got it? Perfect. Okay. We are down to our last question, our very last question. So remember always, the ones that have a higher electronegativity are on the right side. And that's the smaller elements because those protons pull their shells in. And at the top, where they have less shells, right? That means they're smaller elements and the smaller atoms are going to have a higher electronegativity. The ones with a lower electronegativity are going to have less protons or more shells, and that's going to make the atom larger. And when the atom's larger, there's less electronegativity. Yay. Thank you, Jaden, Jesus, Kaylin, Michaela, Ryder, Lamont, Danny. Thank you, Ian. Ahmed, Ayani, Australia, Dulce. You good? This is your last question. Thank you, thank you, thank you. Bam, everybody. Okay, we did it, we did it, we did it. We talked about, okay, Dulce, I will go back to questions 2 and 3 as soon as we finish this part. Okay, awesome. So we talked about the trends in the periodic table, groups versus periods, and then we really focused in on electronegativity. Okay, so if you're feeling pretty good, if you're feeling awesome, you are done for today. I hope you have a lovely 3-day weekend. Bye, Danny. Have a great one. Okay, bye.